welcome to this class. In this class, I'm going to show you how to calculate pH and pOH of solutions. pH and pOH of solutions are used to determine the strength of acids and bases. In other words, the strength of acids and bases can be measured in terms of their pH and pOH values. pOH is used when we are talking about bases, and pH is used when we are talking about acids. That means that pH gives us the strength of acids, while pOH gives us the strength of bases. Now, there are important things I want you to know about pH and pOH. Important things to know. Important things to know. Number one thing to know is that we have to know how to define pH. What is pH? pH is defined as the negative logarithm of hydrogen ion concentration of a solution. Mathematically, we can express pH as negative logarithm of hydrogen ion concentration. In chemistry, whenever we use this kind of bracket to enclose anything, we are talking about its concentration. So this kind of bracket is used to talk about concentration. That means that this hydrogen ion enclosed with this type of bracket is talking about hydrogen ion concentration. pH is equal to negative logarithm of hydrogen ion concentration. That is the first thing to know. Number two is how to define pOH. What is pOH? pOH is defined as the negative logarithm of hydroxyl ion concentration of a solution. So mathematically, we can express pOH as negative logarithm of hydroxyl ion concentration. Now please note this, that acids produce hydrogen ions while bases produce hydroxyl ions. Therefore, just like we use pH when we are talking about acids and pOH when we are talking about bases, hydrogen ion concentration is used when we are talking about acids, and hydroxyl ion concentration is used when we are talking about bases. So this is the second thing to know. Then the next thing to know, number three, is that the value of pH and the value of pOH, sum of them always gives us 14. The sum of pH and pOH always gives us 14. So if we know the value of pOH, we can get the value of pH by adding two of them and equating them to 14. Number 14 to know is this, that the product of hydrogen ion concentration and hydroxyl ion concentration is always equal to 10 raised to power negative 14. Hydrogen ion concentration multiplied by hydroxyl ion concentration always gives us 10 raised to power negative 14. Note the difference between 3 and 4. In 3, we are talking about the sum of pH and pOH, and two of them gives us 14. But in 4, we are talking about products, that is multiplication of hydrogen ion concentration and hydroxyl ion concentration, and the product of two of them gives us 10 raised to power minus 14. Now the next thing to know is that number 5 is that for acids their pH is less than 7. So if you have a solution that the pH is less than 7, 1, 2, 3, 4, 5, 6, we say that the solution is acidic. Number 6, for bases, the pH must always be greater than 7. So if you have a solution that the pH is greater than 7, like from 8 to 14, we say that the pH or that the solution is basic. So any pH that is greater than 7 is basic, and any pH that is less than 7 is acidic. Now the seventh thing to know, number 7, is that for neutral solution, pH is exactly equal to 7. So when we have a solution that the pH is exactly equal to 7, we say that the solution is neutral. Therefore, pH of 7 is used to show that a solution is neutral, or pH of 7 is used to determine the neutrality of a solution. pH of 7 is used to determine the neutrality of a solution. Now, let me give you some examples. Example 1, we may be asked to calculate the pH of 0.05 mole per dm cube of H2SO4 solution. Calculate the pH of 0.05 mole per dm cube of H2SO4 solution. Now this 0.05 mole per dm cube is talking about the molar concentration of the acid, that is the concentration of the acid. Now, the first thing to do, or the steps to take in solving pH and pOH calculations are this. Let me write the steps first before we now solve it. Steps to take in solving pH and pOH calculations. Steps in solving pH and pOH calculations. Now the first step is to write step 1. Step 1 is to write the equation for the ionization of the acid or base. If we are talking about pH or pOH, we are talking about acid or base. So the first step in solving their calculations is to write the equation for their reaction, which is always an ionization equation. In ionization equation, ions are produced. In ionization equation, ions are produced. Just like if we have H2SO4 giving us, or let me use another example. If you have a reaction where AB is reacting to give us A ion plus B ion, this is an ionization reaction. A positive ion and B negative ion. Ions are chemical particles that have charges. Like this, A has a charge, positive charge, and B has negative charge. Therefore, these entities, they are ions. So when we have a reaction that these ions are produced, we call them ionization reactions. Acid-base reactions always give ions. So the first thing to do in solving calculations that involve pH and pOH is to write the equation for their ionization. Okay, that is the first step. Write down the equation for the ionization. This is the first step. Now, step 2. Step 2 is to calculate the equivalent hydrogen or hydroxyl ion concentration produced. Calculate or find the equivalent hydrogen ion or hydroxyl ion produced. Now, I've said that in every acid and base reaction, acid-base reaction, it is either hydrogen ion is produced or hydroxyl ion is produced. If it is a base that is reacting, hydroxyl ion is produced. But if it is acid that is reacting, hydrogen ion is produced. So the step 2 is always for us to find the concentration, find the equivalent concentration. Find the equivalent concentration of hydrogen or hydroxyl ion produced. Equivalent concentration of hydrogen ion or hydroxyl ion produced. That is the step 2. Now, how do we find this? To find this, in the equation given to us, there is always a concentration, a molar concentration given. Now we use that smaller concentration to find the equivalent hydrogen ion, if it is an acid, that will be produced by that concentration given to us, or hydroxyl ion that will be produced if it is a base that is given to us. And for us to do that, we use the equation for the ionization. We write the equation for the ionization and then compare two of them in order to find the equivalent concentration of the hydrogen or hydroxyl ion given. Now, in the equation for the ionization, it always talks about the concentration of 1 mole of the acid. Now, the hydrogen or hydroxyl ion that will be produced, for instance, in A, B reacting to give A ion and B ion. Now, this is always talking about 1 mole of this acid, and then we are talking about maybe this may be hydrogen ion concentration. So we are looking at 1 mole of this acid, how many moles of hydrogen ion will it produce? Then we compare it with the concentration given to us in the equation. How many moles of the hydrogen ion or hydroxyl ion will it now produce? I will make it clear when we start solving the equation. Okay, that is step 2. Now step 3. In step 3 is that if we are calculating pH, to calculate pH, use pH is equal to negative log of hydrogen ion concentration. But if we are calculating pOH, to calculate pOH, use pOH equals negative logarithm of hydroxyl ion concentration. So this is the step 3. In step 3, we go back to the equation. We look at what they asked us to calculate. If they ask us to calculate pH, we use the first equation, that is pH equals minus logarithm of hydrogen ion concentration. But if they ask us to calculate pOH, we use pOH equals negative logarithm of hydroxyl ion concentration. Now let's solve the example 1. Now in solving its solution, in solving the example 1, the first thing for us to do is to write the equation for the ionization of the acid. The acid involved is H2SO4, H2SO4, H2SO4. That is the acid we are asked to calculate its pH. Calculate the pH of 0.05 mole per dm cube of H2SO4 solution. We are talking about this acid. Now, this acid is a strong acid. Why? A strong acid is an acid that ionizes completely. A strong acid is an acid that ionizes completely. And For us to say that an acid has ionized completely means that it has given all its hydrogen atoms as hydrogen ions. Like this one has two hydrogen atoms, so when it ionizes, it must give all the hydrogen atoms as hydrogen ions. So we have H, two hydrogen. It has two hydrogen atoms, so it must give two of them as hydrogen ions. Two hydrogen ions now plus the other component of it, which is SO4 2 minus ions. So this is the equation for the ionization of this acid. We check to see if the atoms are balanced in left hand side and right hand side. We have two hydrogen here, we have two hydrogen here, we have one sulfur here, we have one sulfur here, we have 4 oxygen and we have 4 oxygen, so it is balanced. These 2 minus is just showing us the radical group that this group belongs to, this component belongs to, that it is SO4 2 minus. SO4 radical is written as SO4 2 minus. So the equation is balanced. Now, the next step is for us to find the equivalent concentration of the hydrogen ion produced. The equivalent concentration of hydrogen ion produced. Step 2. Step 2. In step 2, equivalent ion of hydrogen ion produced. Now, let's look at step 1 again. In step 1, we have 1 mole. This 1 mole is presenting 1 molar concentration of this acid. It's giving us 2 molar concentration of this acid. Therefore, in step 2, we ask ourselves that if 1 is giving us 2, then the molar concentration of the acid given to us in the equation, how many molar concentration of the hydrogen ion concentration will it give us? How many molar concentration of the hydrogen ion will it give us? So in step 2, we say that 1 mole of H2SO4 gives us 2 moles of hydrogen ion. Therefore, the molar concentration given to us in the equation is 0.05. So we ask ourselves, this 0.05 molar concentration of the acid, how many hydrogen ion will it produce? So we say if 1 gives us 2, 0.05 H2SO4 will give us what? Let's call it X. Now what to do is that we do cross multiplication. This X going to this one and this 0.05 going to 2. And so we have that X times by 1. X times by 1 is equal to 0.05 times by 2 is equal to 0.05 times by 2. Now X is equal to 0.05 times by 2 divided by 1. And so we have that X is equal to 0.05 times by 2 is 0.01 use your calculator and times it, is equal to 0.01 mole per dm cube. Now this is the molar concentration of the hydrogen ion produced by 0.05 mole per dm cube of the acid. So if one gives us 2, if one of the acid gives us 2 hydrogen ion, then 0.05 of the acid will give us 0.01. If one mole of the acid gives us 2 hydrogen ion, then 0.05 of the acid will give us 0.01. Now this is the calculated hydrogen ion. Now in step 3, we use the calculated hydrogen ion to find the pH. If it is hydrogen ion, like here now it is hydrogen ion, we are using the hydrogen ion calculated to get the pH. And the pH in step 3, we go back to our equation. In our equation, we are asked to calculate pH and not pOH. So we are using the equation for calculating pH. So we use pH equals minus logarithm of hydrogen ion concentration. Now the hydrogen ion concentration we are going to use is the one we calculated, not the one in the ionization equation, but the one we calculated. The one we calculated is this one. This is the hydrogen ion calculated. Now it is this one calculated that we are going to use to solve this problem. So we put the calculated hydrogen ion concentration here to get the pH. So we have that our pH is equal to negative logarithm of 0.01. Negative logarithm of 0.01. Now if we use our calculator and calculate it, we get that negative logarithm of 0.01 is equal to 1. So this is the answer. The pH of the solution, the pH of this solution, the pH of 0.05 mole per dm cube of H2SO4 is 1. So that is the answer. The answer is 1. Now we go to another example. Example 2. Example 2. Calculate the pOH of 0.2 mole per dm cube of sodium hydroxide solution of sodium hydroxide solution Now to solve it, to solve this, again the first step is to write the equation for the ionization. Now looking at this sodium hydroxide is a base. So a base ionizes and acid ionizes. If an acid is ionizing, it gives us hydrogen ion. But if it is a base that is ionizing, it gives us hydroxyl ion. So this one is a base, so we are expecting hydroxyl ion. So in solution, we have sodium hydroxide. This ionizes to give hydroxyl ion plus sodium. Now, this we look to make sure that the atoms are balanced in left hand side and right hand side. We have one oxygen here in the left, we have one oxygen in the right, we have one hydrogen in the left and one hydrogen in the right. We have one sodium in the left and one sodium in the right. So the equation is balanced. This is sodium ion Na plus. Now this is the first step. Now step 2 is to write the equivalent concentration of the hydroxyl ion produced. Hydroxyl ion now because we are talking about base. Step 2. Now for us to write the equivalent concentration of the hydroxyl ion concentration, the equivalent concentration of hydroxyl ion produced, we go back to the ionization equation. And now from the ionization equation, we have that 1 mole of sodium hydroxide is giving us 1 mole of hydroxyl ion. So we go back, we see that 1 mole of sodium hydroxide gives us 1 mole of hydroxyl ion. So in the equation given to us, how many moles of sodium hydroxide is given to us? 0.2 moles. 0.2 moles per dm cube. So we ask ourselves, 0.2 moles will now give us what? Now 0.2 moles of sodium hydroxide will now give us, let's call it X of hydroxyl ion. Now this hydroxyl ion X, if we do cross multiplication again here, cross multiplication, S going to this and this going to this, so we can have X times by 1 is equal to X times by 1 is equal to 0.2 times by 1, so is equal to 0.2 times by 1, and therefore X is equal to 0.2 times by 1 over 1. Therefore, our X is equal to 0.2 times by 1 divided by 1 is the same as 0.2 mole per dm cube. Now this is the concentration of hydroxyl ion produced. So this is the calculated hydroxyl ion, calculated hydroxyl ion concentration. So in step 3, we go back to the equation and look for what they asked us to find. They asked us to find the pOH of the solution. Now, if we are looking for pOH, we use the equation that states that pOH is equal to negative logarithm of hydroxyl ion, where this hydroxyl ion is the one we calculated. Therefore, our pOH here is equal to negative logarithm of 0.2, negative logarithm of 0.2 negative logarithm of 0.2, and therefore our pH, if we find the negative logarithm of 0.2, it will give us our pOH. Our pOH is now equal to 0.699. This is the answer. This is the pOH for the sodium hydroxide. This is the pOH of 0.2 mole per dm cube of the sodium hydroxide solution given to us. So it simply means that if one sodium hydroxide produces one hydroxyl ion, that 0.2 mole produces 0.2 hydroxyl ion, and then this 0.2 hydroxyl ion gives us a pH of 0.699. So we have calculated the pOH as this, the final answer. Now we can go on to solve another example. Example 3. Example 3. Now we may be asked to calculate the pH of 0.2 mole per dm cube of sodium hydroxide solution. Now, looking at this, it looks like the second example we have solved. But here, we are asked to calculate the pH and not pOH. The other one, we calculated the pOH and not the pH. Here, we are asked to calculate the pH of the solution. Now, I've told you that pH is used when we are talking about acid, and pOH is used when we are talking about bases. But essentially, we can talk about pH and pOH of any solution. We can talk about pH and pOH of any solution, only that when we are talking about the strength of acid, we always use pH to talk about it. And when we are talking about the strength of bases, we always use pOH to represent it. But we can talk about the pH and pOH of any solution. If a solution produces OH, it is possible for us to talk about the pOH of it. And if we get pOH, we can talk about pH, because there is an interconnection between pH and pOH, which is that pH and pOH always gives us 14. So there's a relationship. So two of them, sometimes they go hand in hand. So we can calculate pH and calculate pOH of the same solution by using the interconnection between the two of them. So for us to solve this solution, the first thing to do is again to write the equation for the ionization, which is that sodium hydroxide gives us, let's talk about the the ion of interest first before we talk about the other one. Hydroxy ion plus sodium ion. Now step 2 is that we find the equivalent concentration of the hydroxy ion. The equivalent concentration of the hydroxy ion. Now we say that one sodium hydroxide produces one hydroxy ion. Therefore, 0.2 mole per dm cube of hydrogen or sodium hydroxide will produce how many hydroxy ion? So we have in step 2 we have one sodium hydroxide gives us one hydroxy ion, and 0.2 sodium hydroxide gives us X, and so we calculate for X. We have that X is equal to, if we do cross multiplication, we have that X times by 1 is equal to 0.2 times by 1, and our X is equal to 0.2 times by 1 divided by 1, and we have that our X is equal to 0.2 mole per dm cube, the same thing we calculated before. Now we use this as the calculated hydroxy ion concentration. Hydroxy ion concentration calculated, and this calculated hydroxy ion concentration is the one we are going to use to solve for the pH. Now, but look at this now. Step 3. In step 3, we are asked to calculate the pH of the solution. Now, we cannot, this is talking about base, and I've said that in base we talk about pOH, while in acid we talk about pH. And base produces hydroxy ion, while acid produces hydrogen ion. Now, we cannot calculate pH from this directly because it is a base. Instead, for us to calculate this, we calculate the pOH of this base and then use the pOH to calculate the pH. So, this is a base. When you see a base, it's actually pOH. The strength of pOH of a base is measured in pOH and not pH. So, but you can still get the pH by calculating the pOH first and then adding two of them, the pH and pOH, to get 14. So we get the pOH for this base and then use it to calculate the pH. So that should be our step 3. In step 3, because this is a base, we cannot get the pH directly. It is the pOH that we can get. So we use the OH, the concentration of the OH ion, to calculate the pOH. Now we have that pOH is equal to negative logarithm of hydroxy ion, and so we have pOH is equal to negative logarithm of 0.2, and now pOH is equal to minus logarithm of 0.2 is 0.699. Now this is not the answer. We are looking for pH and not pOH. Now for us to calculate pH, now there is an equation I gave you that pH plus pOH, the sum of them is equal to 14. Now we know our pOH, so we put it here and use it to calculate the pH. Therefore, pH plus our pOH is, we calculated it as 0.699 plus 0.699 is equal to 14. So we have that pH is equal to 14 minus 0.699. Therefore, our pH is now equal to 13.301. So this is the final answer. So we have calculated our pH using the pOH. So this one is an indirect process. We first of all calculated the pOH because it is a base, and then use the pOH calculated to find the value of the pH.